My name is Bob Kooima. I am a postdoc here at CCT. I've been here for 6 months now. I come from the University of Illinois at Chicago, which is where I did my PhD. I worked at the Electronic Visualization Lab, where I studied computer graphics, display technologies, immersive virtual reality, autostereoscopy, and well, a variety of other topics, including large-scale terrain rendering and composition. One of the primary goals of the Electronic Visualization Lab was to do work in new display technologies, immersive displays, large-scale displays, high-resolution displays. And so I worked on a number of those things. Virtual reality displays like the Varier, that's an autostereoscopic virtual reality display. It's a 3D display that you don't need glasses to look at. Lenticular Varier that worked on the Dynalax, as well as a number of other tile displays, the Tactile, the Lambda Vision. Oh, the Lambda Vision is a large-scale, high-resolution tile display. Many display technologies. My role was on the software side. I developed a lot of the software that made it possible to create content for these displays, specifically the ability to use a normal PC, your laptop, or what have you, to create an application and then allow you to run that application on a large variety of displays, VR displays and tile displays, sort of write once, run anywhere type of thing, which is necessary in an environment where you're developing new displays. To be able to port software immediately between them is very significant. So that was the role that I played there. For my doctoral dissertation, what I ended up doing was something somewhat more application specific, working with planetary scale data sources, specifically data sources that are coming from probes that we have around the moon and around Mars. These are gigantic data sources. Images and height maps of the moon and Mars, the Earth, that are less than a meter per pixel. A data source like that is many gigabytes, potentially terabytes in size. And what we wanted to be able to do was render these things, explore these things in real time. Not just look at them, but also experiment with them, compose and combine them in different ways. So my research adapted GPU technology to this problem, giving ways of doing interactive composition of extremely large spherical terrain data sets and terrain color map sets. This is actually the renderer that I developed for my dissertation presentation. This thing spends its time at conferences and in museums, filling the role of interactive data presentation device. And in general, when you have something like that, when you have a data visualization that's not being used, you don't want it to just sit there. So what this thing does is it automatically kicks itself into attract mode, just like a video game. You know, when you see a Pac-Man machine, the Pac-Man machine is not sitting there waiting for you to put a quarter into it. It's playing itself. It's making itself look fun. We'd taken this technology to build a museum exhibit in the Adler Planetarium. We've built a screen that's about this size, but actually higher resolution than this, using LCDs that have very small mullions, very small bezels, so that you can put them together, stack them up, and make a very large, very bright display. And instead of the Earth, it shows the moon. But it's not just a model of the moon. It's a constantly increasing in quality model of the moon. We launched this probe last month. NASA launched a probe that's circling the moon now, taking super high-res imagery. Over the course of the lifespan of that probe, it's going to take 100 terabytes of imagery. And we have access to that as it comes down from the moon. We're going to be adding it to this model, the model of the moon, as it comes down. And it's so much data that nobody could ever possibly look at it all. As it comes down, nobody can take the time to look at all of that. And so essentially, the visitors to the Adler Planetarium, they'll be seeing features on the moon for the first time. They'll be, if there's something interesting there, an interesting rock, an interesting crater, what have you, it could be just a normal person who discovers it for the first time. Because of this display like this that we're setting up there, it's really magnificent. It's running now, it looks great, and it's just going to get greater and greater as time passes.